Hey everyone. So today begins kind of that third shift in this big long unit. So the first section of functions, we dealt with radical and rational graphs and functions. And then the second section, we've been dealing with polynomial functions. Okay, this is now the last section of this big long unit, and it's probably the easiest 3 or 4 days we're going to spend in the whole year, okay? And it's on function operations. So we dealt with the concept of functions starting in grade 10 when we introduced, hey, you can replace your y with an f of x. F of x and y meant the same thing. But now what we're going to do with that is we are going to perform mathematical operations on functions. So we can add functions together, subtract them, multiply them, divide them. And then the last kind of topic we'll talk about is something called composition, where we put one function inside another function, okay? But for the most part, this is going to be the most straightforward thing we do in the whole course. So it'll be a good little mark booster for your quiz at the end of this section, as long as you're doing your homework and you're paying very close attention to the details, right? Remember, math is a language and you need to communicate it super, super well, okay? All right, so in your book, we have worked with many types of functions, including linear, quadratic, cubic, radical, rational, polynomial. Coming up after this will be trigonometric, exponential, and logarithmic. Now we will find ways to create new functions by performing operations with these functions. Okay, now this one's not in your book. I'm just going to take you back to grade 10 for a sec. Quick review of how to handle functions. Given the function f of x equals 2x minus 8, determine the following, f of 2. Well, that means instead of x, I'll replace x with 2. So it'll be f of 2 equals 2 times 2 minus 8, and that'll be 4 minus 8, which is negative 4. So f of 2 is negative 4. Remember, we like function notation because it shows us our input and our output at the same time. I know the point 2 comma negative 4 lies on this graph, okay? Okay, f of negative 8, same sort of thing. I'm going to plug in negative 8 for x, and I get out f of, that should say negative 8, sorry. F of negative 8 equals negative 24. Okay, so again, I have on the graph the point negative 8, negative 24. Okay, then this one was slightly different. It says x if f of x is 18. So this time we're telling you f of x. F of x is 18, which means I replace f of x here with 18 and solve algebraically to determine what x is. So that would be, oops, sorry, I still have my ink on. 18 equals 2x minus 8. Bring the 8 over, divide by 2, and I get x equals 13. Now, that still does give me a point. It gives me the point 13, 18. But the trick there is remembering that it's f of x, not x. Okay. All right, so I'm back in your book, and today we're going to look at combining two functions by adding or subtracting. There are two different ways to tell you to do that. I could do it on the top way here. It says h of x equals f plus g of x. That means h of x equals f of x plus g of x. And personally, I would always, even if you're given it this way, I would write it this way first or next, like as your first step. Because I just think it's a better visual, okay? It's a better, for your brain, it's a better visual for you to understand what you have to do here. Same thing with subtraction. H of x is f minus g of x, or written as h of x equals f of x minus g of x. So essentially today we're just going to take two functions, add them together, or subtract them from each other. Subtraction is slightly harder than addition, only because you have to remember that when you're subtracting a polynomial, that subtraction sign has to apply to every term on the other side of that polynomial, or on the other side of that bracket. Okay, so given the functions f of x equals x squared and g of x equals x plus 5, so obviously x squared is the green graph and x plus 5 is the blue graph, answer the following questions. So I want you to figure out what y is for f of x and g of x, When x is -2, -1, 0, 1, 2, you can pause me to do that. Those are the answers you should have gotten. Okay, just reading it off the graphs. Okay, now it says determine the new function and sketch it on the grid. Okay, so we're gonna forget about the table for a sec. H of x is f of x plus g of x. Well, we know what f of x is and we know what g of x is. F of x is x squared. G of x is -x plus 5. This is literally now what h of x is then, because I just took the two functions and I've added them together. Okay, now I want to clean it up a bit. I want to make it look as simple as possible. So we can get rid of the brackets there. H of x, sorry, is going to be x squared minus x minus 5. So if we go ahead and graph that, you can maybe use your graphing calculator as well, just have them in y1, y2, y3, but make sure in your book that you have accurate sketches of them as well. Okay, so that's what it should look like. And now we're going to fill in the table of values from -2 to 2, just like we did for f of x and g of x. I'd like you to do it for h of x now too. And then you start getting really excited because you're like, whoa, look at that. H of x is 11, which is 4 plus 7. H of x is 7, which is 1 plus 6. H of x is 5, which is 0 plus 5. When you're adding functions together, you're adding the y values of the original functions together. So the x values are going to actually stay the same, and the y values get added, or if we're talking about subtraction, the same thing will happen. They'd get subtracted from each other. Okay. Okay, so compare your two tables. Do you notice a way that we could have determined the y values? I got a little too excited. I got ahead of my slides here. Do you notice a way we could have determined the y values without creating the new equation? Yes, we just add the original y values together. Determine the domain and range for h of x. Okay, so the domain is going to be real. The range, I'm going to have to get my graphing calculator out and find that minimum point. The minimum point ends up being at 4.75. So y such that y is greater than or equal to 4.75, where my y is a member of the reals. There will be in this unit a lot of you telling us what the domain and range is, making sure you understand what that new function looks like. Okay, consider the graph of f of x and g of x below to sketch the graph of h of x equals f plus g of x. Well, we're going to do the same thing. We have two lines. We are going to keep x the same, look at the y values, add them together, and create the new y value. Okay. So I started at -8, and I said, okay, h of -8 will be f of -8 plus g of -8. I know that f of -8 is 1, and g of -8 is -3. So that means h of -8 has to be -2. That's a point I can plot for h of x. So I'm going to do that by filling in this table. So you're going to want to pause me, and you're going to want to do this yourself. There's my original f of x's and g of x's. H of x, I'll just add those together. So -1, or -3 plus 1, 0, 0, 3 and -1, 6 and -2. So remember, when you get down to the back end of this table, the point on h of x will be your new y value, but your x value stays. Okay, the x values don't change when you're doing these guys. They will remain consistent. Okay, so now if I was to plot that, I would get this line here. Okay, so this time we did this by getting just the points. We were just looking at a picture and we used just the points. Okay, I want to prove to you that it still worked with the equation. You've been building equations of lines since you were in grade 10. So just as a proof, let's build the equation of f of x and build the equation of g of x. Okay, f of x has a y-intercept at 3, and it has a slope of, let's see here, 1, 2, 3, 1, 2, 3, 4, so 3 over 4, yeah? So f of x would be 3 over 4x plus 3. G of x has a y-intercept at -1 and a slope of 1, 1, 2, 3, 4, so -1 over 4. So g of x would be -1 over 4x minus 1. Okay, so Sorry, I forgot to answer this question first. Did the x values change when we determined the new function? Well, I sort of answered that already, but no, they didn't. The x values remain the same. Did the y values change? Yes. Okay, the y values got added together, 4 points that had the same x values. Okay, now this is where I was getting to determine the equation of h of x. I just gave you f of x and g of x. Now, the one thing we haven't done yet is h of x, so we might as well do it, and then we've got all three of them together. H of x has a y-intercept of 2 and a slope of, looks like up 1 over 2, so a slope of 1/2. So 1/2 x plus 2. So there's f of x that we said, there's g of x. I'm going to add them together and I'm going to see if I get the same thing. So f of x was 3 over 4x plus 3. G of x is negative 1 over 4x minus 1. Now I'm going to add those together. So 3/4 x minus 1/4 x is 2/4 x, which is 1/2. And then 3 minus 1 is 2. I get exactly what I just said I was going to get by building the equation of this line, as I do when I added f of x and g of x together. Okay, so it all still jives, it all still works. Okay, so from the graph to the right, determine the values of f minus g of 2. So that's the same as saying f of 2 minus g of 2. So you need to go to where 2 is. F of 2 is 3, and g of 2 is negative 1. So 3 minus negative 1 is essentially what we're saying there, which would be 4. Okay, f plus g of 0. So same thing. You need to go to 0 this time though. So f of 0 is 1 and g of 0 is negative 1. And when I add those together, I would end up with 0. The order matters very much when you're talking about subtraction. So just be super careful with subtraction, right? You can see that here matters because you ended up with that double negative there. Okay, f of negative 2 minus g of negative 2. So I'm going to go to where f is negative 2 and g is negative 2. And I'm trying to put my ink back on. So f is negative 1. And at g, I'm at negative 3. So I'm going to have negative 1 plus negative 3. So I get negative 4. And then the last guy, I've got f of 1 minus g of 1. So f of 1 is 2, g of 1 is 0. And so I end up with 2 minus 0, which equals 2. Okay. Okay, state the domain of f plus g of x. Okay, so I've got a line here. This guy is, so x is a member of the reals for f of x, and g of x, x is a member of the reals. And remember that when I'm doing the domain, when I'm thinking about performing an operation like this, the x values aren't changing. So if my original existed in all the domain and my new guy exists in all the domain, then, sorry, and if both, I'm gonna just repeat that. If both originals exist in all x values, then my new guy has to exist in all x values, okay? Where that gets a little trickier for domain is the domain has to exist in both of the functions, and we'll see that in a couple of, and in a little bit here. But you have to essentially always just take the overlapping domain between the two functions, and that will be the new domain, okay? But for this guy, because they're both infinite, the new guy will be infinite as well, okay? Okay, so actually, this is the conversation I was just having. The domain of f of x is negative 3 to 6, and the domain of g of x is negative 3 to 8. Determine the domain of h of x, where h of x is f minus g of x. Now, you might say, oh, well, then I can go right from negative 3 to 6, because that's the overlapping region. Except that on this guy, you also can't be negative 3, so you have to take into account that as well. So if I was to just draw this out for you just quickly for a visual, we would have, like, on a number line, here's -3. So the first guy goes from -3 to 6. And I can be both of them. The second guy goes from -3, but I can't be -3, to 8. Just call that 8 there. Okay, and so the overlapping region would be this guy, which is -3 to 6, except I can't be -3 anymore. Okay. So the domain of the new function can only exist where the domain of both functions previously existed. So we end up with -3 to 6. Okay. All right, from the graph to the right, determine the values of, we've done one like this before, so just pause me and you do them, and then I'll show you the answers. So f plus g of -3, going to -3, you end up with 6 plus 1, which is 7. F minus g of -1, again, just make sure you're starting with f. So you got 5 minus 2, which is 3, and f of 4 minus g of 4, you end up with 3 minus 7, which is -4. Okay. All right, so state the domain of f plus g of x. So for this guy, take a look at where does the domain coexist for both of them. So both of them start at -3, but look, g of x goes a little too far. This guy, well, it doesn't go too far for g of x, but it goes too far for the common region. So the common region has to stop at 4. And so we're going to say here that the domain ends up being from -3 to 4. -3 to 4. Okay, sketch the graph of the combined function indicated. So we're looking at f minus g of x. Now, this one you want to play a little bit with. You need to try and get a few points. I know right away, you should pause me actually right away. You should pause me and try this yourself before you start listening to my explanation. Okay, so I assume you paused me, and now we're gonna kind of take a look at this. I know right away, if I'm going f minus g, where we have points that are the same, which is right here, here, and here, okay, I'm gonna get a 0 there. So I know I have the point 0 here, and 0 here, and I have 0 here, okay? Now, let's pick on where x is 1 for a second. Where x is 1, I'm going from like -0.5 to 1 in the g of x. So I've got, I'm sorry, not -0.5, +0.5. So +0.5 minus 1 will give me -0.5. Okay, so that'll be down there. And then this guy, same thing, because it's symmetrical. So the same conversation happens at -1. Okay. All right, then I want to look at, let's say 3 for a second. I'm going f of x. So I've got 4.5 minus 3 would be like 1.5. Okay, so then at -3, I have that same symmetry. Okay, and what are we looking like here? We're kind of looking W-ish. Okay, kind of looking W-ish. Okay, sorry, I had this flashback to Zoboomafoo. Most of you may not even know who Zoboomafoo is. Okay. So if I did this, here I am getting some points, okay? So h of -2 equals 2 minus 2, h of -2 is 0. And I got those guys, okay? These are all guys we've talked about. I'm just showing my work now, okay? And then there is my shape that I'm getting. So sketch the function, we have done that. If h of x, I'm just gonna turn off my ink there. If h of x is f plus g of x and f of x is 4x minus 7, determine g of x if h of x is x squared minus 2x. Now don't shut down because of all of the letters you just heard. It's really not that complicated a question once you understand algebraically what's happening. So h of x is f of x plus g of x, and I know h of x and I know f of x, and I'm being told to algebraically figure out what g of x is. So if h of x is f of x plus g of x, then g of x all by itself would be h of x minus f of x. That's all I'm doing. Now, you have to be careful though, when you put the polynomials in, you have to be super careful with subtraction, because anytime you make a replacement and say what f of x is here or anything there, that has to be, that polynomial has to be in a set of brackets so that the negative gets distributed, okay? This is something you'll see appear on tests a lot. So we've got x squared minus 2x, that's h of x, minus f of x, but now that's going to be negative 4x and positive 7. Clean it all up. The new g of x is x squared minus 6x plus 7, okay? Okay, and then what last, just the second part of this question, what if h of x is 4 minus x? Well, it's the same question though. H of x is f of x plus g of x, therefore g of x will be h of x minus f of x, and I plug in this, what I know h of x is 4 minus x, and f of x hasn't changed. So now I end up with 4 minus negative 7, so that's 11, and negative x minus 4x would be negative 5x. So the new g of x here will be negative 5x plus 11, okay? All right, when performing operations on functions like adding or subtracting, the only value that changes is the dependent variable, the y value. Don't touch the x value. The x values do not get added together. The x values remain stationary, and it's the y values that we would add or subtract together, okay? So here is your work. Like I said, I think this will be kind of a breath of fresh air for you. It'll feel a little easier as we wrap up this unit. Just know that as we wrap up this unit, the next thing to talk about is trig, but we'll get there. Yes, so give this a go, and if you have any questions whatsoever, please don't hesitate to get in touch with me, okay? We'll see you soon. Take care.